So, I'll be the first to admit I don't know anything about Marvel or superheroes, but I think Thanos is loosely based on Titans from Greek mythology. Today we're analyzing a scene from Infinity War, which is an odd title. Is the runtime infinite? What kind of budget did they have on this film? Or is this an indicator of how bland it was, because anything that causes one to stare at a screen for 3 hours is going to feel like forever? Anyway, using the power of plot coupons, or what's called a space stone, Thanos is able to alter the gravitational constant and hurl a moon at his superhero, which normally I'd say is overkill, but for superheroes with more plot armor than Harry Potter, yeah, that's reasonable. Moving on to the physics, Newton's first law is an object's inertia, which is essentially how stubborn it is to get moving or stay moving, will prevent one from being able to move it, especially moons with a lot of mass, unless faced with an equal amount of force. Which reminds me of my dog. She refuses to get up in the mornings, and when she's up, she refuses to stop moving. Force is anything that causes an object to change its velocity, not magic from Star Wars. You see, Newton's second law says force equals mass times acceleration, so objects with more mass are harder to move. Think of trying to lift a feather versus a bowling ball. In space, the only force acting on objects is gravity, so something would have to affect gravitational force, Fg, in order for the moon to come crashing into the planet Titan. Using the space stone, we're going to assume that Thanos increased the gravitational constant and altered the space around the moon so that it would feel more gravity than there actually is. The moon simply is being affected by more gravity than a planet would normally exert on such a satellite. The equation or formula for gravitational constant, g, is F equals g times the mass of the first object times the mass of the second object, all divided by the distance squared. We're trying to calculate the new g. In order to solve the equation, we need to first make assumptions about the problem. In the movie, the characters seem to be experiencing the same amount of gravity they do on Earth, thus we can assume the planet Titan is about the same size as Earth. This means the mass of Earth, or Titan, is 5.972 times 10 to the 24th kilogram. We can assume that Titan shares the same radius as Earth as well. Unfortunately, we have very little information about the moon in Infinity War, so to make our math easier, we will assume it is basically the same as our moon. We can also use the distance between the two surfaces of the moon and the planet. Next, we need a time. We are going to assume that it takes 10 seconds for the moon to crash into the planet because my physics teacher watched another physics video regarding this problem, which used this time, and I'm too energy efficient to change it. Referring back to Newton's second law, we can assume that the net force of the moon is equal to its mass times acceleration. Net force is simply all of the forces added together that are acting on an object. Since the only force acting on the moon is gravity, net force also equals the gravitational constant times the mass of the first object times the mass of the second object divided by the distance squared. Normally, the gravitational constant is 6.67 times 10 to the negative 11th. But not this time. Writing out the equation, we can see that the mass of the moon cancels out on both sides, and so that just leaves the acceleration of the moon equals gravitational constant of the moon times the mass of the planet, divided by the radius of the moon and the planet squared. Our goal is to find the gravitational constant of the moon. Recall the assumptions we made earlier. One important thing that we need to find is the acceleration of the moon. The acceleration is very important in physics. In fact, you need it to solve almost every single motion problem. There are 3 kinematic equations that can be used to help determine the motion of something. They help you find an object's final velocity, its final position, etc. For this problem, we will use the equation final position equals the sum of initial position, initial velocity times time, and half of acceleration squared. Because the moon started from rest, we know its initial position is 0 meters. After spanning the distance between the Earth and the moon, we know its final position is 384,400,000 meters. Its initial velocity will also be 0 meters per second. The total time it traveled, as we said before, is 10 seconds. After you plug in the variables, here's what the equation looks like. Before solving, you can also take away the zeros in order to make it easier to look at. After solving the equation, you'll find that the acceleration equals 7,688,000 meters per second squared, which is really fast. Now all that's left is to plug in your acceleration back into the original equation. Using the assumptions we made at the beginning, you can begin plugging in all of the numbers. Assuming there were no calculator errors, you should arrive at the gravitational constant 0.1983, and all of the other units that go along with it. So, yeah, we just found the new gravitational constant. If you made it to the end of this video, I'm sorry. I know my voice is annoying and I'm bad at this, but I hope you learned some physics, and maybe you could try this out with other movies. If you have any movies you like, you can apply physics to it and try to solve equations. It's really fun. This was a completely new experience for me, and I'm glad I did it for the extra credit. Thanks for watching!